So next we have evaluation of functions. All right, so to evaluate a function means to find the value of the dependent variable given a value of the independent variable. For example, evaluate f of x equals square root of x squared minus 1 at negative 3. Now often you'll see at x equals negative 3, but the x equals part of that is not necessary. When they say at, they mean the thing that follows the at is the input for the function, the value of the independent variable. And it's important to know that, especially when you start doing application problems, aka word problems. Okay? So let me write that out here for you. There you go. It means the input is negative 3. So solution, f of negative 3 equals square root of the quantity negative 3 squared minus 1. Make sure that you plug the negative 3 in, substitute it for every x in the equation, including the one where it says f of x. So it should say f of negative 3. Write that part down. Write this part down. Don't skip it. Write that down equals that. Because later you'll have different functions that you're using and you have to keep track of which is which. This is one of the great advantages of function notation. Okay, so just substitute. And if there were more x's in the equation, I would put negative 3 in for all of them. That gives me square root of 9 minus 1, which is square root of 8, and I need to write that in simplest form, which I get from factoring it as 4 times 2. 4 is a perfect square, so that one simplifies. And square root of 4 is 2, and the square root of 2 is square root of 2. So my answer is 2 square root of 2. Second example, evaluate f of x equals x squared minus 2x plus 1 at x squared. So sometimes we evaluate a function at something that's not a known number. And this is an example. So f of x squared equals, and when I have expressions like this that I'm substituting, I like to, wherever I have an x in my original equation, I like to just put parentheses instead of the x, and then just take whatever you're putting in there and just put it in each set of parentheses. It's just to keep from getting confused. That's especially good if you have more than one term in your expression you're plugging in. So you get x to the 4th minus 2x squared plus 1.